In this recording, we're going to spend a few minutes actually interpreting the data that we have in our flight analysis. But there's one thing that I forgot to do in the last video that I want to do really quickly, and that's just change the report layout for this pivot table. If you'll click somewhere within the body of the pivot table, go up to the Design tab in the Pivot Tables Tools group on the ribbon, and over in the Layout group, you'll see an option for Report Layout. And I'm going to click on that drop down and then click the button to show in outline form. And this just tidies up the presentation a bit. It's not 100% necessary, but you'll notice that instead of having, row names and column names and these obscure labels in the body of your pivot table, it changes it to where the field names are there. So I think it helps improve readability. So let's go back to the original question. Are there peak days and times when delays are worse? And from looking at this data, the answer to that is yes. I mean, keep in mind that the higher the value, so the red values that you see are the places where we experience the highest volume of departure delays expressed in minutes. As you look at the table, the most extreme value occurs, Sunday at 7 p.m. During that hour, that is where we experience the largest total volume of delay. More generally speaking, it looks like the evening hours at the start of the week, Sunday, Monday, and Tuesday, all three of those seem to have high volumes. Tuesday as a whole seems to experience higher volume, as does Thursday. Thursday might not be as extreme, but you see delays starting early in the day and pretty much running all day long. On the flip side, the places where you aren't seeing a lot of delays are really places you would expect. You see the smallest values in the 5 a.m. hour and in the 10 and 11 o'clock hour, where you wouldn't expect to see a lot of departure delays because, relatively speaking, there are a smaller number of flights departing at that time. As you look across this top row, the 5 a.m. hour, virtually all of the numbers there are negative. The only exception to that being Saturday. And if you'll remember from the data set, a negative number in the delay column means that that flight actually departed a few minutes early. So it seems that the flights that start at the very beginning of the day actually get off a little bit ahead of schedule, but that as the day progresses, that the delays tend to grow. Now, that in and of itself makes sense if you think about the dependencies of flights throughout the day. Very oftentimes, a flight departing on time in the middle of the day is dependent upon that plane having arrived on time from a different location. So it definitely makes sense that you would see the propagation of delays throughout the day. We can definitely gain some insight into the answers to our questions using the data that you see here. However, it doesn't tell the whole story, and you would definitely want to explore it from other vantage points before presenting an analysis to organizational leadership. I'm not going to go through every variation on that theme here, but one that I will show you pretty quickly is, what if you decide to look at it using a different summary statistic? When you think about analyzing the data using the total departure minutes, there are two factors at play there. Is it really that the delays are greater at that time of day, or is it the fact that there are more flights scheduled at that time of day, and just by virtue of the fact that more planes are in the air, that's what's driving up the departure values? Well, a quick way to adjust for the number of flights is to change the summary statistic from a sum to an average. And I'm going to do that really quickly just to show you what it looks like. If you go back over to value field settings, I'm just going to change it to average, click on OK, and let's just assess how that changes. In this example, things are still pretty consistent. It still seems to be pretty heavy in the evenings. Tuesdays and Thursdays seem to be consistently delayed. But you also have a new problem area. While 7 o'clock on Sundays is still a bad time for delays, the day and time combination with the on average highest delay is now Fridays at 9 o'clock. I'm not saying that looking at these values as expressed in terms of total delay or average delay that one is better than the other. I think the bigger point is that they're actually two complementary perspectives, and that if you're doing a thorough analysis, you would want to look at it both ways and really think about the insights that are created from looking at it from multiple complementary perspectives. And that's certainly what we're going to be doing in this course.